10 million trillionths of a second after the beginning, a bit of space-time, about 100 million trillion times smaller than a proton, came into existence. There was no distinction between the four fundamental forces of nature. Gravity was the first to split away, and a few trillionths of a second later, the strong nuclear force broke away from the others, releasing a vast amount of energy that caused the universe to expand by a factor of 100 billion trillion in a few more trillionths of a second. At the end of this rapid expansion, a group of elementary particles began to condense, and the expansion of the universe dramatically slowed to the normal rate. As the universe ended its first trillionth of a second, the temperature cooled from about 100 million trillion degrees to 10 billion degrees, cool enough for protons, neutrons, and electrons to form. At about the 100-second mark, with the temperature at 1 billion degrees, neutrons and protons were able to stick together. About 300,000 years later, the temperature had dropped to 3,000 degrees, and the first atoms formed. Matter and energy became decoupled, and for the first time, light could travel freely across space. The oscillation from day to night is the most fundamental unit of time, and our awareness of time may be mostly a result of the fact that the Earth rotates on its tilted axis as it orbits around the Sun. The word month is close to the word moon, and is a unit of time derived from the cycles of the moon's phases. From Earth, the moon is apparently still and does not rotate. However, the moon is in a synchronous rotation with the Earth, rotating one counterclockwise revolution over the same time it takes to make one counterclockwise orbit around the Earth, essentially keeping the same side facing us, but rotating nonetheless when observed from space. The regular pattern of the tides is a natural ticking clock, like day and night, the seasons, the phases of the moon, and menstruation. These regular events are a kind of natural time that is so obvious that it goes unnoticed. The circle is everywhere in nature, and the circumference of a circle is pi times its diameter. The exact value of pi has an infinite decimal expansion, which never ends and apparently does not repeat. Supercomputer calculations have determined over 1 trillion digits of pi, and no pattern in the digits has ever been found. How many drops have fallen in the water? How many drops are falling in the water? How many drops will fall in the water?